Hi and welcome to the Prusa Podcast. It's a kind of different look this time. We're trying something new. The topic for this podcast is AI in 3D printing, and it's four of us here. I'm joined by Honza from the content team,
Hey.
Elena from the AFS team,
Hi.
and Joe. Yeah, Joe, I don't know what team you are. Okay, yeah, so AI in 3D printing, AI is everywhere. I'm kind of annoyed with how often I can see it, but I think there are some actual legitimate uses for AI. And Elena, we have you here, which is wonderful because you've been working with AI quite a bit recently, right?
Yes, we have just started developing our own AI solution for error detection, and we are introducing it into Connect and also applying it in IFS team.
So error detection, so you're talking about processing a camera image.
Yes, we are processing the camera images we have trained a model that is open source model, but we have custom trained it on our printers data. Yeah, we've collected a data set within the company, and we got some classes. We defined the classes that we wanted to train, and now we have a model that can help us detect which picture it is. Yeah, if it is, for example, a spaghetti monster.
We all know that.
If it is an empty sheet,
Okay.
or for example, if your camera is suddenly pointing at a different angle.
I've actually played with it. I believe all employees, everyone who is a Prusa employee has this
Very encouraging.
special button in Prusa Connect. The users can't see it, but I had a chance to play with it, and I've recorded some of the use cases. So whoever is watching on YouTube or Spotify with video, they can look at it. We will kind of describe what we see. I also hope, maybe can you bring your mic a little bit closer? The stand should let you, take it. I just hope that it will pick up your voice nicely. But yeah, so basically, for now, it's how I see it from the user perspective, how I experience this. It's a new button in Prusa Connect, and I guess it just sends the model into the neural network.
It is a neural network. It is a neural network that is pre-trained on millions of photos. But when we tried it with my colleague Mark, we tried the raw model, and we decided that it needed a bit of fine-tuning because, probably 3D printers are not very well represented there. So we collected the images. I myself, have been going around departments to take pictures of the. And what is cool about this models? You can notice that we have two. Yeah, we have two variants. Yeah, and they are just for us for now. Yeah, we are testing different parameters there.
I see you send it to both, and it gives.
Yeah.
Each gives its answer, its confidence.
Yeah, exactly. Yeah, it gives how it thinks it matches a certain category.
Yeah. And I've tested different use cases. So the most obvious ones are where it can tell you that print is in progress. It looks fine. I find it interesting that you trained a use case where there is no print sheet on the build plate.
Yeah, well, this might be issue for like security or if somebody.
I think it's amazing. It's amazing because if I start to print in Connect, it might one day be able to tell me, the printer is not ready. It doesn't have the print sheet on.
I think ultimately, if you have the print queue and you have to basically set the printer ready, we could do this
automatically.
That we see that there is a sheet, and we can see
it's empty,
and you can go.
That sounds awesome, and then there are some other use cases like perf print is finished. I guess kind of the telling thing is that the print head is and not anywhere near the print, or how do you know how like
as we have trained the images that we have used for training, they are all of the 3D printer, of the print on the 3D printer. So it might not be so well, if you take a picture of a print on a table, it might not detect it well, or might not be very confident, on what it's seen. So, and what is also interesting here is that as we've used different cameras, because when we were collecting the photos, so we use different cameras, different angles, so it's very general, now, you don't need to have a specific camera.
I would like to highlight that very much, because that's really...
And
incredible.
And actually use, I don't know, your old phone camera or Raspberry Pi camera, whatever camera you have.
I'm using an ESP32 camera, and I just put it anywhere, and it works.
Exactly,
So it's not like it's a built-in camera in the printer, and it only knows that one angle, and it's trained on that one resolution, one sharpness.
Right,
You can just actually, there's a dedicated app where you can just send any photo into the model and it will give you the answer, right?
Yeah. So
I would like to do a little plug. Take a look at our video, how we make our printers. We mentioned the amount of machines we are running constantly at the company, and not just on the farm, but everywhere around the company. It is a huge number, and the fact that this is where it pays, that we are using our machines ourselves, because of this we have so much data,
and we don't have to use any user data. I guess that's a big disclaimer that's worth mentioning, that we are not using any images from anyone else outside of the company, just internal data for now.
That's also a plus, We are also planning to we are now using these models on IFS.
Because the harvester has cameras, right? Can look at.
The harvester has a camera, and it takes an image of the print when it's in process, and so that's how we can catch early spaghetti.
So it seems like the spaghetti detection is working already really quite well.
It is working. We have my colleague Mark has set up a channel on Slack for us, and
send me your spaghetti.
Exactly, so we have a Slack channel, and every time our farms have a spaghetti on them, we receive a message there, and the whole team can actually react, to whether to stop the print or just continue.
There's one more use case, case which it can detect, which again surprised me, but it's, I think, very useful, and that's when the model detects that it's not looking at a 3D printer.
That's maybe useful. We thought that it could be an option, because sometimes, I don't know, your cat comes in the camera, or I hope to cat.
Same.
It can be the issue.
That's why I have the enclosure, because otherwise the cats would be on the printer all the time.
Right. So we thought it might be practical.
I think it's great. I guess because the output is what do you think? What the model thinks it's looking at, and the confidence. By the way, the confidence is also very interesting, that you get a number of representing the confidence in what it's looking at.
So we get the exactly. I'm trying to get the confidence level at every class that we're detecting, so then we can maybe modify, or I'm planning to introduce more classes. For example, layer shift. I'm actually collecting the data set for that right now.
Because then I can imagine, for example, in the rare case that the camera just, your cat bumps into the camera, it's not looking at the print, you can decide how to handle such case, rather than just going into your mobile phone, going panic mode with notifications like, I don't know what's happening, printer, something crazy.
So in the future, it's possible that we can get automatic reaction to
pausing in.
and as you mentioned, the confidence. What is quite cool with some large language models, the text ones, you can I think OpenAI is also through the API you can get the confidence rate for each token, and you can see how sure the model, because it's basically probability, right? It is basically guessing what the next token, or you can imagine it as the letter should be, and when it starts to go off the rails, you can usually see how it starts hallucinating. You can see that the confidence is dropping, or the probability number of that token.
I can imagine, for example, if you had a 50% spaghetti, that maybe Connect could wait. It could wait for the next picture and see what's happening with the confidence. Maybe some little piece of support broke, but it actually doesn't matter for the print. And the spaghetti will disappear. Confidence will go up in print, going fine, low in spaghetti, and it can just continue.
Yeah, some prints can recover from like small.
And I would like to talk about the types of failures, or how are you internally classifying the types? You know what I mean? Basically, spaghetti.
Yeah.
We have the clean bed or no bed. We are looking somewhere else. What are these classes?
Yeah. Well, we have 7 at the moment. Yeah. So spaghetti probably the most important one. Which is a messy print in general, even if it's like a huge shift with spaghetti. Yes, the important thing is that there is spaghetti. Then we have the empty heat bed, we have the empty sheet, then we have the wrong angle, we have the perfect print, like finished print, perfect finished print, and print in action, and I think that's it.
Yeah, and you asked us internally to give you more photos of errors so you can add more cases.
Yeah, I'm working on it, yes, because the
problem is that the printers don't fail much.
Do you go around the company? Do you go around the company and just break other people's prints?
No, I don't break them, but I'm watching. I'm on watch constantly.
I mean, put some lotion on your hands, and when there are no farmers at the print farm, mess with it. I mean. The farmers would probably kill you, but you would have a lot of data.
Yeah.
Oh boy.
Well, my favorite is testing department. Yeah, they have.
That's right.
They have interesting cases.
I mean, I wish you could know our testing. They are so meticulous, and they document everything. And we are basically we still have a lot of like Mark 2.5s at the testing.
Yeah.
So we get the data from way back, because we still support those printers.
Yeah. We have minis and like everything, all types of printers.
So to get a little bit more in the nerdy details.
Yeah.
How long does the fine tune take?
The fine tune took the part that took most of the time was the data set creation.
I specifically meant like the run on the GPUs, and maybe this we can talk about the setup, because AI and large language models are kind of my hobby.
So. No, it took us less than a month, I think, to get the whole thing working and to customize our parameters and find the best.
Yeah, and I guess the goal is to one day have it in Connect or in our printers
but now
somewhere.
That we have it, it's easier because we can easily modify that. And work more and add more classes and twist with the parameters. So.
Yeah. And I would say for the people who are not into this, the data set is the data where we have the pictures of the fails and they are classified, and in the model training, the quality of data is the king, and also the quantity.
Yeah.
And you can imagine it. like if you are teaching your kid and you are showing them the pictures. So the more examples you show them, the more confident they are in describing what is happening.
Mm-hmm.
But it can confuse the kid if you give them two vague images with descriptions which are maybe synonymous but not the same.
Yeah, well, that's why we, for this first model, we manually kind of double checked everything,
Yeah.
every single picture,
Yeah.
so that it makes sense.
I mean, when I'm fine tuning, it is still a little bit of a magic. It is still a little bit of magic. Most of my fine tunes turns more into a lobotomy of the original model than improving it.
Well,
And so right now it's image, which is it's image file to the matrix of pixels, and the other dimension is the text description, or the maybe doesn't have to be text, but what it is, what you're looking at, like manually edit. Could you technically add, let's say, the load cell data dimension, where the printer would also send the reading from a temperature, thermistor or something?
into this model, into the image processing model, I don't know. I don't think it's needed.
I'm not saying it's needed. I'm just wondering, if it could maybe detect
As a data set, yeah, why not? You can.
Well, it can be interesting, but we would probably have to create model from scratch to look at the data. But in this case, as we are running so many machines, it is a huge advantage for us because we are collecting all the sensor data from all our machines into
internal machines. I would just stress out again.
Internal
in-house.
Into a giant Grafana. Well, Grafana is the user interface.
Yeah.
We store the data, and in some cases, especially I remember from very early in the development, we were able to set the logging level as high that we could recreate the model from it.
I remember. Yes, I was very early in the load cell development, years ago now, when I was testing the self-leveling. I had some problems, and it was the Alan developer came and he showed me Grafana, and he opened the single probe, the data from single probe, and he had such resolution that he saw coming close to the sheet, then tapping it, then going slightly against, then going up. I'm like, are all our printers in house sharing all this data? It would be kind of crazy on our network.
Oh, well, it is not that much data, but I don't think people know this, and this might be topic for one of the next podcasts. We have simulators for the firmware, and you can basically plug it to virtual printer. So we can which simulates the extrusion, and you can. We developed it during the investigation of the famous 602 issue, which is the artifacts on printing, and which is for the whole 3D printing community, right? Or for all the 3D printers. But this turned out to be a very nice way to check for if those minute surface deviations, if they are happening, for example, in the firmware, or if they are happening, you can remove some of the variables like the filament and physics and whatever.
And perfectly circular extruder gears and everything in software.
Yes.
And if you still see 602, then you know that it's something else.
Yeah, but the 602 is compound thing. It is from 20 little things. So, but you can just isolate some of the variations. So I think we should look more into training the training models for this, and I think it may be possible to predict the print some of the printer fails before they even happen. That would be very cool.
Yeah, actually, that's a parallel that came to my mind. Is technically Mark IV or Excel or our new printers are running something similar with the load cell as you do with the images, where it is sending the load cell data into a model rather than like going through FOSS, and it can detect like this is a bad touch, so it touches again a bit to the side.
You may be correct that Alan was doing some sort of magic.
Yeah, like collecting data and taking them manually. So I guess it's happening in all sorts of departments. Okay, so I guess the first thing that would come up to everyone's mind, maybe even when they tune into this podcast, when they hear AI 3D printing, would not be this, but probably the first thing would be modeling, like creating 3D models.
But before we go there, we were just chatting a little bit before the podcast.
Were you? Yeah.
I think it might be cool that that we maybe open some of the weights we fine tuned to the community. What do you think about it?
Well, I haven't them prepared.
No.
Once they're prepared.
Well, not right now.
Okay,
not right
well,
now, but eventually.
But yeah, eventually, yeah. At the moment, we are working on this. Yeah,
Yeah.
and we want to make sure that it actually
Yes.
works and makes
Yeah.
sense and
Yeah,
is useful for the customer. Yeah, but later, yeah, for sure, we will.
Like we could collect
definitely-
Voron community. We could collect some images from the Voron community and could work on their printers as well.
yes.
Let's
There's infinite possibilities.
Yes, people play with it.
Yeah.
But I would say if you have some if the viewers or listeners have some interesting ideas, we can brainstorm brainstorm on it.
Okay, so now we can move on to 3D models.
Sure.
Okay. Yeah, 3D modeling. I think we've all played with AI in text, which is, I would say, much simpler. As you said, Joe, it's like guessing the next word with some confidence. So it's, in my view, it's kind of random word generator a little bit, or at least I'm sick of seeing ChatGPT texts online. I think how about you too?
I mean, I would say depends who you compare it to. But I'm super proud of the content we put out, and it's difficult for the very generalistic AI model to produce content on the comparable level. But if some other companies don't have such a strong content team, maybe it is useful for them to get out the press release. I think for that it is.
We will take it. We will take the compliment. That's sure. That's fine. Thank you.
Thanks. Yeah, but you're absolutely right that the texts that are put out by ChatGPT or whatever are very generic. They're kind of averaged from everything. It's scraped from the internet. So it's kind of difficult to see some kind of specific style or the kind of like the soul or something the creator usually gives into the creation.
And I feel like this is only multiplied when it tries to do 3D models. Like, it's like blobby. What I tried was like blobs with some textures. It was kind of weird.
It's doing massive leaps, I would say. It's doing like really interesting progress. Like, I mean, it's I don't know, year and a half ago, we were kind of stunned when we looked at, oh my God, this sort of like software can generate an image of an avocado-shaped chair. And it's like, wow, you can just type, make a chair look like an avocado, and it does that.
Mm-hmm.
And it was a tiny image, like 64 by 64 pixels. And nowadays, I've been running a local installation of Stable Diffusion for around a year, I think. And now I'm able to do like 2-minute animations with it. And they are pretty consistent. So the progress it made is insane.
Fair enough. This is the perfect segment into a short pre-recorded interview. I talked with Peter Farrell, who is a creator on Printables. Peter has over like 1,100 models, like 1,000. Yeah, that's it. We're already hearing Peter now.
Hey, I'm Peter Farrell. I'm a 3D modeler, and today I'm going to show you how to use displacement and stable diffusion to add details to your model. I'm going to go through a few examples, one of making a medallion, and then I will show you how to use stable diffusion image to image to basically take low quality images that are part of the UV map and make them look really pretty and high resolution. This is a coin that I made using Blender and stable diffusion. Basically, I start off with some basic geometry. In this case, it was just kind of like a flat cylinder. I took an image that I made in stable diffusion, I basically gave it a prompt. I said I wanted to have something that kind of looked old and it looked like a magical coin, and I used a whole bunch of adjectives and things like that to kind of get to the point where I got this picture right here. And this picture then I use to basically cut, I'm going to say, or create geometry on my cylinder. And then you can see kind of like the results of using Blender. Yeah, I used displacement and I created this coin. So there's one, and this is a really, really basic process. This took like, probably maybe, 20 minutes altogether to do. Figuring out how to do it took a lot longer, but once I figured it out, this process became really quick. And it's a lot of fun. All right, so here's an example of like a pattern. This is actually, I was working on a model of Kermit the Frog with a Hawaiian shirt on. So I have this flower, and as you can see, it's a little fuzzy. That would actually, a lot of times this would work just fine. But if you wanted more details, and let's say you wanted these little parts of the flower to have more detail, that's pretty easy. So you go into image to image. I'm using absolute reality for my stable diffusion checkpoint here. One thing I'm going to say is in my negative prompt that I don't want it pixelated, so I will put that in there. I'll put fuzzy, hazy. I'll put like out of focus, and then it will take your low quality thing. And you can see like we're getting sharper now. We're getting a little more details. Actually, some details are getting taken out and other ones are getting put in. All right, so right now we have this model, and it's, we got a Kermit, and I know that I want to put that flower on his shirt, let's say, right? Mm-hmm. We're going to go to faces. We're going to go to tries to quads. It didn't look like it changed all that much there, but it probably did. And then I need to, this is kind of an important thing. When you want to add poly, when you want to do this displacement technique, you need equidistant squares. And in this case, we have rectangles. This is not going to work. We're going to have stretched out flowers. They're not going to look right. I'm just going to create some more poly here. All right. I don't want to spend too much time doing this because that's just really boring to watch. Now we'll do some down here. These are bigger squares. We got all those cuts. This is where now I'm going to do subdivision surface. I'm going to do a simple one first. Sometimes you have models that have all these different parts, and there's like 8 or 9 UV maps, and they're all for different parts of the body. And so this ability to make vertex groups allows you to selectively basically pick what you're going to displace. So now I can go to new. So then I could just take this one here, and then hopefully this works. There you can see. Cool. Now it's adding the flowers like over the shirt. And you can see, like I told you, it's not going to come out right. But anyway, you get the idea. I'll go to the horse one. It's not something I'm really proud of, but it was something, again, it was an experiment, and I found out how easy it was to like basically change like the style. So in this case, we have this horse, right? I've used my technique, my displacement technique. I've taken, and this is the one on the right in this case is the original of what the mesh kind of looked like when I added displacement. And the one on the left, all I did was say is like, I had to do Art Deco. So I was like, oh, I want to make some of the, and you can see like, especially on the saddle here, some of the lines and decorations, like it did. It made it more kind of like a little more Art Deco, and it changed a lot. The eyes are still where the eyes need to be. Everything, it's just using the map. And so it folds around the model as it's supposed to, but it does. It changes the design.
I'm just showing Peter's profile on Printables. Like I said, he has like 1,200 models of incredible detail.
Impressive.
Yeah, I think this is the right way to do it, when you take AI and use it as a tool somewhere in the middle to help you achieve something, because it's still your creation. You're just using some new high-tech tools, and it's not just I'm gonna type a few words and generate an image and there we go. Because I mean, you can see it everywhere nowadays. Somebody did that Harry Potter in the Balenciaga style video, and it was original, it was fun, it was unexpected, and then then everybody learned how to do it, and now Facebook and YouTube is completely flooded with that, and it has no added value. It's just all the same kind of prompt. You just switch it from Harry Potter to Breaking Bad or whatever. So this is something I really, really like and appreciate.
And to describe it a little bit more for the people who are just listening, he was using Stable Diffusion, but you can use Midjourney for this too, or DALL-E from OpenAI,
an image generator,
to create an image. And then he used this image to displace the surface of a 3D model to customize it, basically by the image. Maybe Mikolas can describe it in more precise terms.
Yeah, this is a technique that's used for decades in gaming industry, where you actually do this on the run. So you send to the GPU a very low poly mesh, and the texture, you send it to UV maps. So that's saying how the wrapping, imagine like a chocolate egg or something, how the wrapping goes around this model. And then the GPU does some very simple vector math, and it shifts the vertices to create more detail. What Peter is doing, and really was fascinating interview. We talked for 2 hours. I cut it down to 5 minutes, but Peter is a wonderful, wonderful guy experimenting with this. He stamps the texture into the geometry like actual forever, so he can export it with the displacement modifier. He can export the mesh, and it will actually already have the detail in.
So as we are talking about it, Blender is quite daunting for someone who didn't use it before. But as you were guys speaking, I realized that we have the SVG emboss in the slicer now.
That's right.
So with one little step added to this process, you can prompt the image generator to make it vector.
Yeah.
And then just use a simple vector converter to get SVG, and you can use it in the slicer.
Yeah.
So I think this would be a very nice, quick little tutorial we can put out in a couple of days.
Yes. And then another thing Peter was doing, I love the creativity. When you get an AI and you just approach it as a tool, and you take it for what it is, and you try all weird things, and something comes out of it. The image to image, where he had a model which already had a texture. It was either for example, public domain scans from museums, or Peter was using models from like Legend of Zelda, like 64 by 64 pixel textures on extremely low poly models, and using image to image, he either upscaled the texture to create like wonderful detail, or using image to image on the texture, he was changing the style. So we were looking at models, and he was like, I can make this horse cyberpunk, and like with one sentence, just one run through Stable Diffusion, and it will change the texture, and he can change the model completely.
Yeah, this is actually what goes like beyond regular programming, beyond the AI, because this text prompting, is not easy. We have used it also in our model, and when we describe the image, also like it understands you sometimes better, depending on which word. So it's a bit of fighting, with it, trying to make it understand you.
I mean, there's it is almost like regular profession, prompt engineer.
Yeah. Exactly.
And you can make a pretty penny. You can make a pretty penny. And as we are sometimes, I'm sometimes talking with Mikolas, I'm showing him the more advanced prompts. And it's like, what the hell is that?
Yeah, or you can write. You can make an AI which will take bad prompts and change it into good prompts, and then feed it into another AI which will actually take use of the better prompts.
Yes. So, and I think you guys showed me that you were playing with generating some of the 3D models directly.
Yeah.
Or am I jumping?
I'll tell you.
We wanted to talk about it. Yeah, sure. So I was kind of playing with it with these 3D generators a couple of months ago. I think back in November or so, and back then it was really, really basic. Like it could probably create something like a cartoon model of an apple, or basically some kind of blob that reminded you of an apple or something like that. And I tried it again a couple of days ago, and I was surprised how good it became. Like it's doing some really
good
crazy
or better.
It's getting really good, I would say. But on the other hand, it's strictly limited to things that are already online. It's not very imaginative. So if you would say, I would like to generate an image of a TV with human legs and dragon wings or whatever, it would be kind of lost because it wasn't trained on this type of thing. It's much easier with images. So I tried something crazy, like give me a 3D model of a loaf of bread in a cyberpunk style.
That's easier.
And well, technically, I mean, a loaf of bread is kind of simple. And it did something really interesting. It wants you to describe the surface as well, like the texture. So you can type in what kind of texture you want to see. You're limited to something like 3 or 5 keywords. So if you compare it to Stable Diffusion, where you use something like 100 words or something like that, it's very, very basic. But it actually did something that had the properties I wanted. So,
really?
Yeah. I mean, yeah, sure. At this point, you can't really imagine that you would say or type, like, I want a 3D model statue of Nathan Drake from Uncharted in an action pose, something like that. It wouldn't really work, but it's about the data you have for training.
Yeah.
And I think this is a kind of a big topic we should also discuss.
Yeah, the data in this regard is a king. I have a couple of remarks. I think as you were mentioning the Stable Diffusion and how rapidly it evolved, and these image generation models, it is, the data available for that, the amount is incredible. Yeah, incredible, and it's so easy to scrape from the web.
It's also unethical.
Yeah,
scrape.
Yes, I will get to that. Right? What did they find out? That Midjourney was just teaching it on the Marvel movies.
Yeah.
That when you prompted right, it gave you the exact screenshot from the movie, and that is, and this is very not subtle. But for example, in this regard for 3D object generation, I think the kings are, for example, Luma AI, which they are doing 3D scanning app and Gaussian splats, and they are using the data from the people. They are teaching the neural network.
I guess here you at least opted in. Well, by agreeing to
now here's the catch.
Okay.
If you prompted to give you a Pikachu model, it will give it to you, and the legalities will be very, very interesting, because they will say, hey, we didn't put it in. Our users have in the terms of service that they should not put anything copyrightable. Yeah. But I think this will be very, very interesting, because if you are following this at all, you've probably seen that the New York Times is suing OpenAI because they were training on their whole database. Because it is very nice data set for training, because they go back for ages. It is nicely written, good English.
The smoking gun there is the AI generated watermark in images, right?
Yeah,
Which is kind of hilarious when you think about it.
It's a really interesting. When I mentioned I'm doing some experiments with animations, there are also different models for animations, and there is one that's like version 1.1 and 1.2, and if you use, I think, the older one, it has watermarks. It generates watermarks, the style of stock image database.
Get the images
Across the video. Like, it's insane. It's not like random.
across the video. That's even worse. That means they
Every
That's the
single
preview.
video you generate.
and it will be interesting what will happen, because, for example, as I spoke with about the Luma, I'm pretty sure that Pokemon Company will not be happy about that. And you spend millions of dollars training these neural networks, and it will be interesting because it is very difficult to get this out of the data set without full retraining. I've seen a couple of papers. I didn't read them through, because this is too deep for me to understand. But the fact that there is a research how to unlearn something out of the model is very interesting.
Must be hard. I
Yes.
think it's easier just to teach it again.
Yes.
And
And for example, you know that in some European cities you cannot take picture of some buildings because the architect has the rights for the commercial purposes.
like
So-
Atomium in Belgium.
It will be a bloodbath, and I hope that, because I generally think that what is happening in AI is a very good thing, but these early days it will be very interesting. And if I get back into like the models from the scans, it is very difficult to get the training data to be exact. So, and especially with 3D printing, a lot of the times, if you don't want to make a figurine, which basically you do not care about the dimensions, it will be very difficult to get the data sets. But you know, we run Printables, which is very, very large. I would say by the incentives, we have very nicely curated data set. So we see a lot of scraping, right?
We are blocking a lot of attacks on our database.
Especially recently with China ramping up the investments into the AI to get it's a great lot, and all around the industry. So be careful where you upload your models. And I think it will be very obvious because the data set of these high quality models and sculpts, in the whole community, there are just the styles of the designers are very distinctive.
Yeah.
For example, our friend Fotis Min, or
Eastman, Wexter, and anyone from Printables who look at typically very distinct styles.
Yes. So, and as the community is quite small and very tight knitted, it will be interesting when you see some of the models popping out, and they will be just trained on these on these data. And I'm not very happy. I'm not very happy about it. That it's very difficult to fight against it.
I know Carl's just did like a no AI thing on every model. The author can decide. I think it's just like a license thing where they are prohibiting, like they are saying, please, I'm badly paraphrasing, but please don't train my model. I don't think the someone can still download it.
I mean,
Yeah,
I think it will not be respected. I mean, well, what it will work for is that you can prevent like in the robots .txt prevent like OpenAI, Microsoft, and these companies will respect it. But then you will have thousands of the hundreds of startups where they raised in this craze raised a lot of money, and now they need the data to train the model. So they will,
and there are some tools that can kind of scramble an image, so it's unusable in scraping. But I'm not sure.
It poisons the image.
The image. I think it just kind of mixes up the tags. Like when you have a picture of a mouse, it's gonna say it's a cat or something like that. So, but with 3D models, you have direct access to the data, to the vertices and stuff like that. So it's gonna be much more difficult, I would say.
I want to again just state that we see attacks on printables all the time where people try to scrape it. We have pretty good measures how to prevent that. Of course, you can't prevent. Any one of us can download a few models from designers, so you can only detect it once it goes up in scale and it's clearly not standard usage. And once that happens, our banhammer is pretty swift. I do like that. But the whole ethical question, and I know a lot of artists are rightfully very mad.
Greg Rutkowski.
Yeah.
It's one of the most common prompts in Stable Diffusion.
Yeah.
Like, I want this dark fantasy, blah, 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 in the style of Greg Rutkowski.
And you understand why the art,
and he's like super pissed about it, and I like, no wonder.
It's hard to put copyright on the AI generated.
And I think the people who are doing these kind of sketchy things, they are thinking, oh, it's like, it will. No one will notice. Until they notice.
Right. I have something more kind of like fun, I guess, to show you where. So the AI models right now, I think we agree that the chat models are more mature than the 3D ones. The image ones maybe are somewhere in the middle. So I thought, what 3D modeling software uses text? And that's OpenSCAD, which we used for a very long time in the initial years to create all parts of our printers. These days it's a mix.
Basically, you are programming the model.
Exactly, yes. And so I tried to make model in ChatGPT in OpenSCAD with ChatGPT, and the results were a little bit hilarious. So
before you get to it, just a little bit, just a short comment. It's like when you want to use AI, something like a text to 3D object, and you want to create something that's functional, like some sort of bracket, and then you would start describing it as, okay, so I need an L-shaped bracket with 4 holes on one side, and this hole should be this big and this big. You would type all that into some sort of like text to 3D, but you can also pretty much, if you know this, you
might as well just make the model.
Either in Tinkercad or maybe in OpenSCAD, because it's not that difficult to learn for these basic shapes.
So this experiment was pretty quick, I think pretty funny. So I just started by telling ChatGPT, do you know OpenSCAD? It was like, yes, I know OpenSCAD. Cool. Can you make me a code that makes a cube? And it's like, yeah, sure, that's pretty straightforward. You make a cube, dimensions, this is it. So I took the code, copy-paste into OpenSCAD, and sure enough, it created a cube. And I'm like, fantastic. So it works. It's working. So then I was like, what's something when I was learning OpenSCAD that's kind of tricky, and that's chamfered edges.
Yeah, you make 4 spheres and then just wrap.
You have different ways to do it, exactly. Or you can create more cubes, rotate them, and then subtract them from the original cube. It doesn't have a built-in chamfer feature. You can code it yourself. But I'm like, yeah, this is all over the internet. It must be in the learning data. So I told ChatGPT, can you please make a cube with chamfered edges? And it was like, no problem. And it created weird. So it created a cube. It did subtract cubes from it, but only in the corners. But luckily, ChatGPT 4 can understand images. So I tried 2 times and it didn't work. So I just gave it the image back, and I'm like, what do you think? Do you think this is what I wanted? And it was like, oh no, the image you provided appears to show a cube with modifications, but it's not a chamfered edges. So I'm like, can you try again? And it did. And now it's like, did subtract the cubes along the edges, but it didn't rotate the cubes. So
close yet so far.
Yeah. I'm like, yeah. So I just gave it the image back, and it tried again, and then it created a weird cube with like pillars in vertical edges.
I mean, imagine if somebody saw the OpenSCAD for like a second time, and you ask them to do the chamfered edges. I think some of the iterations would look quite similar.
Yeah, it's like me when I was learning OpenSCAD. Then it created something very interesting. It created a code that's very close. If you think about it, it created cubes, it rotated them, it put them on all of the different edges. So it was super close, but I don't think it understood it was super close. So I tried a few more times, and I was like, look, you've tried several times, it's clearly not going well. Can you search some online resources to learn how to do this? And it was like, yeah, sure, I can do this. It was Bing and searching internet, and there must be a million tutorials online. So I hoped it would at least copy paste some online code, and it returned me a huge prompt like, so you're supposed to use the Minkowski function, and this is how it works. I was like, I'm not interested. Just give me the code.
That is quite a long reply. Especially with how lazy the GPT-4 became.
Yeah. But it gave me a huge reply, and I was like, I don't care. Just, can you do the code? And it tried, and it got this close. It got super close. So it chamfered all the edges except for the edges of the top face. And I was like, you are so close. And I gave it the image. Only the top face is missing the chamfers. Can you fix it? And it did. And it just.
So it's almost like when you ask the image generator to generate a nerd without glasses.
Yes, it's the new Turing test. Create a nerd without glasses. Like, you can try it. Yeah. So I personally don't think this is like too feasible right now. It feels like it's just trying random pieces of code.
But I mean, proper prompting goes a long way. I mean, I sent you. I was talking about this with Nicholas yesterday, right?
Yeah.
And he was like, "Oh, ChatGPT, it cannot do this."
Yeah.
So I said, "Challenge accepted," and I spent like hour writing a prompt and instructing it how to do it, and I made a quite cool snowman picture.
Yes.
The only thing was that
the nose,
the conical nose was the other way around.
So the pointy side to the head.
Yes.
And the prompt was funny because the prompt was like it could interpret it this way. Basically, it was like pointy going this way, and
it is. I mean, there's a lot of prompt guys. If somebody is interested in this, how to get the models to do what do you want, and I use some of these. And when you are working on your prompts, there's a lot of iteration, and you get it to work on one use case, and then instantly when you try something similar, it goes to hell. So, yeah, but I think you could get pretty good with this.
I think if you train it or more just OpenSCAD codes rather than everything literally, then
I mean, as you mentioned that there must be a million tutorials. I think it will definitely not millions, but if in the written form, if it's searching, there will be, I don't know, 100 tops. And to get for it to get a general idea is not enough.
Especially since even as humans, there will be like 5 different popular approaches how to do this, and they are not cool.
And if they probably fine tune on this data, but if you would look at the Mark, I think some of the early Mark IIIs, the parts were still made in OpenScan. You have just the part and the image of it, but you would need to have very exact text prompt which would output that OpenSCAD model. And that is nowhere in the data.
Yeah.
Nowhere in the data. So you would have to get all the OpenSCAD models which are available on the internet and write the prompt for them as you wish.
Yeah, it actually changes perspective. Yeah, your perspective.
I see you truly understand what I'm saying.
How you see things. Yeah, it changes how you communicate with AI, and you need to sometimes okay, how we as I think as human brains, we assume a lot of things.
Yeah.
Well, we have kind of more knowledge of obviously than AI, so we assume a lot of things. But then you need to change when you're prompting, you need to change your perspective totally.
And the most hilarious thing, I don't know if you guys, if you guys know it, but especially for someone who doesn't work with much large language models, some of the models, they react to things like, if you do your job well, I will tip you $200.
Oh yeah. Write it like your job depends on it. That's
No. I need a quick and very precise answer, or I will lose my job. And it's like, oh yeah, so sorry that you're in this situation. Let's get to it.
Yeah. That's also how you can trick it to do things which the authors prohibited from doing. This is gonna save someone's life, and the AI is like, oh no, I better do it, I guess.
And if you are playing with a lot of the models, I think this is called alignment with some of the values. So sometimes you can see where the models were trained because they don't want to talk about certain things and stuff like that.
Yeah, so I guess to close it up, there's one more fun use case that didn't come to my mind until you shared a picture on Twitter. I still call it Twitter. I will forever call it Twitter. Where you compiled Prusa Slicer and you've made different fuzzy skin.
Yeah,
but you haven't coded for a very long time.
Yeah, especially I never coded in C++. But it was magical. I know a lot of people know GitHub Copilot, right? So the first try, I just wanted to, I got it to compile, and now I want to see a result quickly. So I just selected the fuzzy skin function and just prompted to do it the way I want it. After the show, I will show you. I have some of the prints from the new fuzzy skin.
Oh, yeah, you printed it. Cool. Tell me, what did you change? What did you didn't like, or what did you want it?
I didn't want it to be that random.
Okay.
That random. I wanted to create more like satin finish.
I see.
And I just prompted, and I didn't even read the code. I just did approve change, and compiled it, and I did full yellow.
And then you put it to pull and west.
No, no. I think Wojciech and the slicer team would sliced me in half.
Yeah,
but it's fun.
I mean, for fast prototyping, if you liked what it does, you could polish it,
and it works. This works so well on the code because I mean, can you imagine how much data is there to train the models on? It is incredible, and the code is usually very well commented, unless it's code I write because.
Yeah.
But yes,
that's cool.
This is very. I think this is the best time to start learning how to code. Because I imagine, I remember when I learned how to program when I was little. I mean, I didn't have internet all the time, so I was like searching in the book. That was crazy, right? Then you Stack Overflow, and you can Google for the bugs, right? But now you can just ask AI to fix the problem or explain your code. It is amazing.
No, I love it when I just use it as as we talked before, like as a tool which helps me get to the result faster. I still have to do the work.
Yeah, it is not for production ready code, right? But
I have to do the creative part. I have to have the idea. But if I have it and I prompt it well, then it can maybe get me there a bit faster than I would normally if I just did everything manually. But I think there is a very thin line between it actually helping you and you spending so much time making the perfect prompt that you're just like, I should have just done this manual and I would have it 5 minutes ago.
Yeah. Usually this is the way, because I mean, you do not have when you have the code like this and it is more complex. You do not have like the map of the code and how it all plugs together in your head. So when you need to debug it, it's quite difficult. So sometimes, I usually do this late at night, and when I'm tired, I just like try to regenerate it multiple times until it works.
Yeah, it's something similar with the visual side. Like you have a certain style. If you draw, if you create something, over the time you create your own style. And with the AI, I mean, I was trying some really cool stuff with Stable Diffusion and ControlNet, which allows you, for example, you take just a couple of cubes in some kind of isometric view, and you say, okay, turn these cubes into buildings, do a Fallout style building or a BioShock styled building, and it's gonna do that, and it's gonna be pretty good. And then you will import some other object like a cylinder, hoping it will create a skyscraper in the same style. It's gonna look slightly different. So if you would try to import it into a game, it wouldn't have the same level of artistic design.
So if used right, you would take the outputs and you would put your own, style. You would redo it a little bit so everything is consistent, but you will get the inspiration. You will get almost there. Yeah, I think we would love to see what everyone else is doing with AI in relation to 3D printing. We've talked about AI vision, processing camera images. We've talked about modeling and all the different text to 3D models and OpenSCAD. And Peter Farrell showed us how he uses already the existing tools in a very creative way to create models. And we talked about programming and text, images, all sorts of ways that you can already use AI to do something maybe faster or better. So if you're using AI in any way that you find interesting, feel free to share it with us on social media. Just tag @Prusa3D. You can use hashtag Prusa Podcast, or honestly just send this to us via email, info@prusa3d.com. We would love to see it, because whenever we think about something and then we put it out to the community, and then the community goes crazy with all the different ideas what they can do with it.
I would like to give a thing to think about for the community and for the designers and people who are deeper in 3D printing. I would love for people to think about how to watermark the 3D models in a way that basically the watermark is not sliced, but
it's there.
But we can how to not poison the data, but
give it a signature.
Keep the credits.
It doesn't have to be signature, but I mean you can use maybe some internal geometry which wouldn't slice, or just with a tiny artifact. But it would be pain to remove it from the 3D data to fine tune on it, because I think this will be soon we will start to see some of these models, and it would be nice that we can suggest something to the designers that their work and style is protected, or at least there might be proof that the data were used illegally, because I think this is very, very important for now. So this is just an idea.
Okay, perfect. Thank you all for coming on the show. I hope this new format was fun. If you like it, let us know, or if you have some suggestions or what to do differently. We would love to go into more topics like this. So we'll see what comes up next. And until then, happy printing.
Yeah, happy printing, everyone.
See y'all.